Hey guys, welcome to PK on Tech. In this video, I'll take you through how to build visualizations in Python using the matplotlib library. Matplotlib library is a comprehensive library to build static and dynamic charts. I am on the matplotlib website, and as you can see, there are a number of chart types that you can use. There are the basic chart types, the usual ones, usual suspects, the line chart, scatter plot, bar chart, a stack plot, etc. And you also have some advanced visualizations, some 3D charts. So we'll take a look at those, and we'll also talk about subplots. There are some simple prerequisites to get us going. So let's take a look at what those prerequisites are. The prerequisites are quite simple. You need to have Python installed. If you don't have Python, let's take a look at how you do it. If you already have Python installed, you can skip this step. We'll also set up a virtual environment, and many people skip this step. I recommend that you always work in a virtual environment in Python. We'll briefly cover how to set up that virtual environment. I prefer working in a Jupyter Lab environment, Jupyter Lab or Jupyter Notebook. You could use any other IDE of your choice, but we'll briefly talk about how to install Jupyter Lab. Again, if you have done all of this, you can skip forward. And finally, we'll install matplotlib. So let's get going. If you don't have Python installed, head over to python.org and click on this download menu option. Here you will see the button to download Python. Download Python from here and follow the default steps to get Python installed. In case you want to work in a specific version for any reason, there are just other versions that you can go ahead and install. But if you're new, just go ahead with the latest version. As of the recording of this video, we have the version 3.11.1, which is a newer version that has come up, some really new features that we'll talk about in a future video. So I already have it installed, so I'm going to skip this step, but do follow, do get it installed and follow the basic steps. So once Python is installed, the next step is to start working, creating a project structure. So I'm in this folder C projects tutorial, and I'm going to be creating a virtual environment here. My recommendation is always to work in a virtual environment. As you start building Python projects, you don't want packages in one project to mess up and impact some other project. So it's always recommended to work in a virtual environment. It's quite a simple step. Let's see how you do it. So head over to your folder, and the command is python -m, the module, venv, and the name of the virtual environment. I'm just going to be calling it my_env. Hit enter. It might take a couple of seconds, and it's created the virtual environment. How do you know that it has created a virtual environment? It would have created this folder called my_env. So let's take a look at what is there in this folder. So it has the include lib scripts, share, and a configuration file. You don't need to worry about all of those. So the env has been created. The next step is to activate this virtual environment. To do that, you need to invoke the activate command, which is in the script folder, which we just saw, and just call activate. And when you activate your virtual environment, it'll prefix your folder, your path with the name of the virtual environment. So you know that you're now working in this virtual environment. That's it. Now that you have this virtual environment set up, any packages that you install are localized to that environment and are not going to impact any other projects. So please do this step. It's highly recommended. Next, let's install Jupyter Lab. I prefer working in Jupyter Lab as it gives a number of benefits over the classic Jupyter Notebook to me, particularly the tabs and visualizations of CSV file, etc. And once you install Jupyter Lab, you will see how convenient it is to. Now that you have your virtual environment set up, the next step is to install Jupyter Lab. I really like working in a Jupyter Lab environment. It gives you a number of benefits over a classic notebook. It has that you can work on multiple tabs. It has the CSV visualizations. You get the terminal window, and it's generally a good environment to work when you're start building your visualizations. To install Jupyter Lab, it's a simple command: pip install Jupyter Lab. So let's do that. So let's run the command pip install Jupyter Lab. It might take a couple of seconds, and once it has installed, you just type the command Jupyter Lab to launch Jupyter Lab. It's finished installing the Jupyter Lab, but before we do launch Jupyter Lab, let's install matplotlib, and we also need to make sure that the virtual environment that we created is available in the Jupyter Lab. So there's one additional step that we need to do. So let's take a look. To install matplotlib, as we saw previously, you just do a pip install matplotlib, hit enter, and in my case, it's already available, so it's going to run through pretty quickly. It might take a couple of seconds in your case. So we have installed Python. If you didn't have it, you have created a virtual environment. You have installed Jupyter Lab, and now you have installed matplotlib. One final step: inject the environment in matplotlib in Jupyter Lab, and we can get started building our visualizations. Next, let's install the IPy kernel module. So to do that, all you need to do is pip install IPy kernel. And once the IPy kernel is installed, the next step is to install the virtual environment within the kernel. So to do that, let's use python-m. The module will be now IPy kernel install, and we'll use the -- user, which means it's going to be within the user's home directory rather than the global directory. So it's always better to use -- user, and then finally the name of the virtual environment, in this case my_env. Oops, I have a typo. It should be -- name. And there we go, installed the kernel spec. We are all set to launch Jupyter Lab. And to do that, the command is Jupyter-lab, hit enter. Once you hit launch, run the Jupyter Lab command, it opens up this environment within your default browser. In my case, it happens to be Chrome, and you will see a browser tab opened up like this. This is the landing page for Jupyter Lab. On the left hand side, you will have your folders in the folder that you are working in. That's where it starts. That's the root folder, if you will. And on the right hand side, you will see the landing page and a few options there. You have the notebook, the console, the terminal, and the terminal. You can open other file types like the text file, the markdown file. And if you are using external extensions, plugins, you can do it here. So you are ready. We are ready. So let's get going here with building our first visualization. To create our first notebook, go to File, New, and Notebook. And when you do that, it's going to prompt you to select the kernel. If you recall, we created a virtual environment called my_env, and we installed it within the Jupyter Lab kernel. And I'm expecting that to see as one of the options here in the kernel options. And you do see it here, my_env. I'm going to select that. So hit select, and we are ready to go here. So the first thing is to import pyplot from the matplotlib library. So let's do that. Import matplotlib.pyplot as plt. Import. We're also going to import pandas as pd. We're going to be using that as our for data frames. So hit enter. That looks good. So let's do a simple line chart. I'm going to mock up some simple data here. So let's say I have a list of values, which is going to be my X as 1, 2, 3, 4, 5. And my Y is, let's say 10, 20, 30, 40, and 50. So to plot this, all I need to do is use the PLT object that we previously saw and use the plot method there and say X comma Y. And if you look at the signature of this plot method, it has a variable args here, but it says plot Y versus X as lines and or markers. So let's see what this does. So this is all we need to do a simple line chart. So I'm going to say plot um, X and Y and as a line chart and plt dot show. And here is our very first simple chart. And that's it. This is we are in business here. Now let's customize this. So I'm going to say plt dot title my hello world chart. I'm going to create some X label as X and my Y label as Y. Shift enter. Okay, there is a typo here. Shift enter. And this is my very basic line chart. It doesn't do much, but it's it's a something to get started. Let's now do something a bit more involved. Let's read from a file, from a CSV file in a pandas data frame and use that to plot our line chart. Next, let's take a look at a slightly more involved example. What I want to do here is plot the stock price of Apple for the last 30 days. To do that, I'm going to go to Yahoo Finance. And if you type in the ticker Apple and go to the historical data option here, and you can download the data, it, it has the data for the last 1 year. I've already done that here, and this is the data that you can see. And this is one of the useful things about Jupyter Lab. It has a very nice visualization for CSV files. So let's plot the data, Apple stock price for the last 30 days. So let's read this data set. So I'm going to read this CSV file. So using our pandas module that we have already imported. So if you go up here, I have imported pandas as PD. To read the CSV file, the method is read underscore CSV. So I'm going to say apple.csv. And you can look at the first 30, you can do a head, and let's see what we see. And you see the data, it has the date, the daily open, high, low, close, adjusted close, and the volume for Apple here. What we are interested in is in the last 30 days. So I'm going to say the tail. So as of the recording, this is the last day, the December 9th, and going back 30 days. So looking at the example here, so I had my X and Y, and I'm passing that to the plot method. So let's do the same thing here. So in this case, my X is going to be from the data frame, the date, and my Y is going to be from the data frame, the close price for Apple. And I could do the same thing now here. So plot, call the plot method, pass the X and the Y, and then call the show. And when I do that, you get a line chart like this. it's obviously unreadable because it's the dates are all cramped in there. But this is the you could say this is the trend for Apple stock price for the last 30 days. Let's see how we can fix this, format this X and Y, and make it a bit more readable. So the first thing I want to do is change the size of this plot. So I want to make it bigger, slightly bigger, and also change the color, give the X and Y labels, and let's see how we can format this date in the X axis so it becomes much cleaner and readable. Let's change the size of this plot. I want to make it a bit bigger. It's more readable. The dates need to be nicely aligned. So let's see how we can do it. So in the PLT object, there is a figure method. And let's look at the parameters for this signature of this method. You'll see there is a fixed size parameter here, and it takes the width and the height in inches. There is a default setting here, and which is specified in your rcparams file, and that's 6.4 by 4.8, I believe. You can double check that. And I want to change this to make a bit bigger, so I'm going to say fixed size equals 10, 8, and let's see what difference does it make. Okay, that's much bigger. So you can play around. So that's sizable enough for me. Now the next thing is to change this dates, format these dates in the x-axis so they are more readable. So let's take a look how we can do that. There are a few ways you can change this orientation of these labels. I'll show you the easy one, which is using the xtext method. And if you look at the signature here, there is a rotation parameter that you can pass, and the rest are all default. We can keep it as default. In the variable args, there is a rotation parameter that we can specify. So I'm going to do that rotation. Let's go with 60 degrees and render it again. And you see the dates now nicely aligned. So the last 30 days ending in December 9th, and that already looks so much better. So let's make a few more improvements here. Let's plot some tick marks here, some markers. Also give the y-axis and the x-axis labels. And let's also take a look at how we can format these dates using a formatter. Let's customize this a bit more. Let's look at the what options do we have. So if you go back to looking at the signature of the plot method, you can see a number of different ways where you can format, and there are some example signatures here. So if I scroll down, you will see one of the examples says you can change the color, the marker, the line style, the line width, and the size of the marker. So let's try this. I'm going to take this as is, and let's customize this or tweak this a bit. So I'm going to change the color to, yeah, I'll keep it as green. The marker, I'm going to change it to an asterisk. The line style, instead of dashed, I'm going to make it solid. The line width is fine, is 12, and the marker size is 12. So let's run this and see how that looks. That looks better. The marker size, it looks a bit too prominent for me, so I'm going to change it to 6. That looks too small, so maybe 10 is a good compromise. Yeah, that looks much better. And we are getting into a shape where it is looking pretty decent. We'll make some small changes. Let's set the title. I'm going to say Apple stock price for the last 30 days. Also set the label. That's date. And the Y label is the close price. that looks so much better. Yeah, so this is a slightly more involved example of a line chart reading a CSV file. So just to recap, we use the read CSV method to read the Apple stock data, get the last 30 days, change the size of the figure to 10 by 8 instead of the default. The labels, the X labels were all squished up, so we are going to change that. We change that by rotating it by 60 degrees, and then we change some of the default parameters in the plot method, change the color to green. We introduce the marker. There are a number of line style options. We are going with the solid. We can change the line width and the marker size, and then we set the title, the X label, and the Y label. So there you have it. We'll talk a bit more about how to use the plot date method for time series data towards the end of the video. If you recall, when we were setting the figure size, one thing I mentioned is around the default size that matplotlib uses, and that default goes for a number of other options like the color, the size, the markers, the fonts, legends, so on and so forth. Fortunately, you can set the default or configure the default the way you want it using the RC method on the PLT module. So if you want to change your default figure size to something else from the default, so you can do that. For example, you can change the figure size using the RC method. So let's see how you can do that. If I look at the signature of the RC method, you you specify the group as the first parameter, and the second parameter is the actual value. So for example, here they have given us some examples. So in this case, they can change the font and specify the values, which happens to be a dictionary. You can do that. I'm going to change the default size from to 10.8, the width of 10 and a height of 8 inches. So let's see how you do that. So in our case, the group is going to be figure, and the value would be the fig size. And I'm going to say it is 10.8, 10,8. And when I set that, now this will become the default for every plot that we chart. Obviously, we can change that. So if I go back to our earlier line chart and rerun that, the plot renders with the default, which happens to be 10.8. If you want to reset back to the default, you could do something like this: plt.rcparams.update, call the update method, and I believe it is plt.rcparams default. So now it has gone back to the original default. So if I rerun this, it goes back to the default size. So just a quick tip there to how you can change the default settings in matplotlib. Obviously, the group you can change to other settings like the font, marker size, axis, legend, stick labels, and a whole variety of other options. I'm going to leave a link in the description for the documentation on how you can change this. Next, let's start making a simple bar chart. Before we do that, I'm going to put a simple marker. I think it's a bar chart, so you can just to visually indicate that the section is a bar chart. So for the bar chart example, I have a simple data set here. It's the revenue mix for the last 4 years for the ride sharing company Uber, 2018 to 2021. And let's do some simple analysis using a bar chart and a pie chart. The revenue mix for Uber is broken down by these categories: mobility, delivery, freight, and other. So let's plot a simple bar chart, let's see for the last year, for the latest year, 2021, how does the revenue mix stack up using a bar chart? And we'll do the same using a pie chart. So before we do that, so let's read this in a data frame. So read CSV over revenue mix dot CSV, and let's look at the data. So we'll say df.head. It's the same as we saw here. And what I want to do is get this row value. So I could say df.log, and within the df, I'm going to say year equals 2021, close params, and I'm going to put this in data. So if you now look at data, it should just have one row, and it does. And I'm going to, what we need is these categories as the x-axis, and these values are as the height of the bar chart. So let's see how we do that. So first of all, I want this column, so I can say columns. And when I do that, I get all these columns, including the year. So I don't want that. So let's slice that. So I'm going to get 1, 2, 3, 4. So I will need to do 1 to 5. And I'm going to do a list of these, a list of this. And that becomes our X. So if I look at X, those are the column values or the categories that I want. And now I want these values as the bar height. So I'm going to say dot values here as the bar height. Actually, I just need all the values except the first column. So if I go back to data, this is what I have. So if I do df data.ilog 0, I should get the same thing here, except I don't want this year. So I could say dot columns, same thing that I did here, 1 to 5. Actually, I'll need to do this, df dot columns. Yeah, that should work. So this becomes my bar height. So I have my X and Y, if you will. And to plot a bar chart, all I need to do is, we saw the plot method before, and in the PLT module, there is a bar method to plot the bar chart. So if you look at the signature here for bar chart, Shift Tab, you see the X and the height, the X-axis and the Y-axis, and then it has it default width of 0.8. We can change that. And we'll talk about this bottom parameter, and that's used to make a stacked bar graph, which we're going to go through next. And then there are some other parameters, alignment, and some variable parameters. You can customize this quite a bit, just like the line chart that we saw before. So let's do the basic plotting, which is, let's plot the X and the height, and plt.show, and I get a simple bar chart which shows for the year 2021 how is the revenue broken down. This is billions of dollars, so across these segments or categories. Of course, I can change the customize a bit, same as before. I can put the title Uber revenue for 2021, and then I can specify the X label, category, and the Y label, revenue, and I can specify dollar, something like this. And this is a basic bar chart. Let's take a look at a bit more involved example, and we'll make a stacked bar chart from the same data. Let's see how we do that. Next, let's do a stacked bar graph. A stacked bar graph is useful if you want to see a relative decomposition across segments. So in this example, a stacked bar chart would be useful if you want to see the revenue across the years 2018 to 2021 as the x-axis, but on the y or the height, the bars, I would like to see the breakdown across this category. So, and the size of each bar or the segment would show the how it stacks up against others, as well as the whole overall revenue. So let's see how we can do that. Okay, let's start working on our stack bar graph. First thing, I'm going to put a label indicating this section is for a stacked bar graph. And let's read that data frame, read that data again in a data frame. The data we are looking at is the Uber revenue mix for the last 4 years, broken down by these categories. And we want to see for each year how these category segments stack against each other and also against the overall revenue. So first thing first, let's again read this in a data frame. Read CSV Uber revenue mix.csv. Let's make sure our data frame is good. It is looking fine. The x-axis is going to be the year. So it'll be the years. So I'm going to say year here. That'll be my x, and my y values will be the each one of these categories. However, we are going to stack each one against another, right? So we want in this order. So let's take a look how we can do it. So let's start with the mobility first. So I'm going to say plot.bar x, which is the year, and my y is, or the height of the bar is going to be mobility, and that's it. So let's see how that looks. So it should be just one bar, and we'll fix these x-axis when we in a minute. It's and I'll show you how to do it. So this looks fine. So these are the mobility numbers for each one of the years. And one thing I want to change the width of this bar. That looks too wide. So I'm going to say my width is 0.25, and I'm going to say width equals W. That looks much cleaner, better. So now what I want to do is, if you recall last time when we saw the signature of the bar chart, there is this parameter bottom, and that indicates if we are creating a bar, what is below that bar, right? So in mobility is our lowermost bar, so I'm not, the bottom is none, which is the default. However, I'm going to put in the delivery, and I will and I'll stack up on top of the mobility. So in this case, I'm going to say bottom equals df mobility. Okay, so we have our mobility numbers and the delivery numbers, and you already get a visual indication that over the years, the delivery numbers have been increasing. There's not a whole lot of increase here in 2019, but 2020 and 2021, and we'll mark these percentages or the actual values, so you can see these numbers. The delivery numbers are overtaking the mobility numbers. So and that's the useful of a stacked bar graph, you can see how the relative size of each bar against others as well as the whole. Right now, next I want to put in the freight numbers. So let's copy this over, and I'm going to say my bar is the height is the freight, and now my bottom is the mobility plus the delivery. So let's see how that looks. Oops. And you can see that is looking good. So we have the mobility, the delivery, and the freight numbers. It's been increasing, not as much as the delivery. And finally, we want to see the other category, which is the miscellaneous. Everything else Uber is bucketing under other. And now the bottom would be, and the order is important, is going to be the freight. And that completes the stacked bar graph. It'll be useful to show the legend. And I'm going to say legend. That'll be useful. Oh, the legend is not showing up because I've not specified the label. So let's do that. So label equals mobility, label equals delivery, and label equals freight, and finally label equals other. And now the legend should show up. It does. So that's great. So let's put in the X and the Y labels. So as before, I can just copy over from here. So I'm going to say the title is Uber revenue. The X label it'll be year, and the revenue in dollar billions. And that looks really good. So now let's see how to fix this, or at least my way of fixing this decimals. So one neat trick, or at least the trick that I use to remove these decimals, is instead of specifying the labels here, I can specify the index. What I mean is I can take this as a range. I can do a length of here. So I get 0 to 4, 0, 1, 2, 3. And I don't need this. And what will happen now is it is going to, oops, I need one more parenthesis. It's going to show 0, 1, 2, 3. And we can then use the xticks method and specify that the ticks as x and the labels is the year. And that should do it. So that looks much better. So the next step is actually to show the percentage or value in this chart, and let's see how we can do that. Okay, to show the labels, what we would need to do is iterate through the rows of the data frame and read the actual revenue for each one of these bars and use the text method on PLT to write that. So PLT has a text method. So if you let's look at the signature. So it has the the X index or the X value and the Y, and that will be the height at which the label gets shown, and then S is the actual label, the text. So we'll need the S, so X, Y, and S, and optionally the color. Let's say we want it as black. So this is what needs to be called. Now the question is, what is the value for x, y, and s? So we'll need to iterate through the rows. So to do that, so I can do this. So for I row in df dot so df, I want to skip the year column. Columns 1 to 5 and iter rows. And let's see what we get. I'm going to comment these two guys out here and say print row. Let me comment out everything else as well here. So I get these values as expected. Now, what I want to do is create an inner loop and loop through the values of for each row. So I can say for j in range 0 to length of the row, and so each one of those values would be the actual revenue. So I can say revenue equals row of j. Okay. Now, so I have my x and the label, but the y is tricky because it needs to add up the previous value. So let's create a variable, previous revenue. Actually, if it is the first entry, then I'm going to set it to 0. So if j equals 0, previous revenue equals 0. I don't need this. Else, the previous revenue will be the revenue plus previous revenue. And then I can call this plt.text. So x will be I, y will be the revenue plus the previous revenue, and s will be the revenue back. So if I run this, it should work, I would think. Let's take a look. It's almost doing, except it is writing at the top of the bar. And to correct that, so what I could do is I could divide this by half. So somewhere it will come half of. So if I want this for this bar somewhere in the middle, I can say half of this. So let's do that. Okay, that's better. We can make some small tweaks. So the x is shifted to the right. So what I could do is I can just say 0.1 maybe. Okay, x minus 0.1. Okay, that seems to be centered. That actually looks decent, except these values here are jumbled up. And maybe what you could do is you only want to show if it is greater than certain amount, right? So maybe if you could do if revenue greater than 0.5, then do this. Yeah, that looks much better. So as you can see, you get a nice trend here. So the delivery numbers have actually taken over the mobility numbers for Uber in 2021. So you could have already made that inference using the size, but this makes it crystal clear. So that's one way to show the labels. Unfortunately, there is no out of the box method. I'm sure there are other ways you can do it, but this seems to be my way of doing it. You can easily change this label to a percentage. So what you would need to do in that case is instead of the values here, revenue, you need to just divide by the total revenue and you'd have got the percentage. So that's a stack bar graph with values. Next, let's take a look at how we can do a pie chart. And for the pie chart, you're going to use the same data that we use for the bar chart here. So if you recall, we did a simple bar chart for Uber revenue for 2021. So we could do a pie chart with the same data. Let's see how we do that. I'm going to copy over these values, this piece of code here, and let's put a text indicating we are making a pie chart. So pie chart, shift enter, and I'm going to copy this bits of code. So the we want to filter for the year 2021, and I'm just going to extract the values other than the year, and so that will be my labels, and the slices that I want to show in the pie are the actual revenue numbers. So let's take a look at what these show up as. So these are my labels, that's perfect. And the slices are the actual values for revenues across these categories. And a pie chart is a good visualization for similar to the bar chart when you want to see not the exact precise amount, but rather as a slice and how it stacks against other slices and the overall pie. So to use this, to plot this, we need to use the pie method, appropriately named pie method. And if you look at the signature, and it has the X, which are the actual slices, and the labels, right? So which is what we're going to use. And there is a number of other parameters which are optional, and there are some default values which we can change. So let's do the basic thing here. So I'm going to specify the slices and the labels. I'm going to say labels equals labels. And let's, oops, I need to show. And it shows up something like this, which is fine. So we know that the delivery and the mobility are the highest values. I'm going to change. We need to show the percentages. So to do that, we can use this. If you go back to the signature, there is an auto PCT. And let's take a look at what it is. What's the help on this one? Auto PCT none or str or callable. So we can use if it is in the format string, the label will be format percentage PCT. So that's what we are going to use. So it's just going to be a format string. So I can say auto format equals, and I'm going to say percentage 1.1 f 1 decimal, and this is regular Python format string. There is a typo there somewhere. Oh, auto format. It should be auto PCT, and that looks much better. So, and you can see that the delivery is, if you compare against the bar chart, when you have a data like this, maybe a pie chart is a better visualization tool. You get a good sense of how the revenue stacks up for a year. So we can give a title here. Same thing, plt.title, revenue, Uber revenue mix for 2021. And I can also show a legend. You can position this legend, but it's a you get the idea how you can do a pie chart. So whenever you have a data set, so there is a choice that you have, and it's depending on the data set. So if the number of categories are less than 5, a pie chart makes a lot of sense. If it is more than 5, then it gets crowded, and maybe a bar chart is a better way to represent that chart. So that's a pie chart. Next, let's take a look at subplot and what's the difference between how we are doing and what's the value of a subplot. Hey guys, so far in this video, we have been working with a specific way of creating our plots on the calling methods on the pyplot module. And that has been an individual plot. So we saw how we created a line chart, a bar chart, a pie chart, etc. And in each case, we were directly calling methods on PLT, if you recall. For example, plt.py, plt.bar, and plt.plot in case of a line chart. However, there is another method to create plots, and that's using the subplot method. Or there is a wrapper method subplots where you can create multiple subplots in one single call. So let's take a look at that. Before we do that, it's important to understand the matplotlib object hierarchy. And I borrowed this from the real Python website. It's a really useful way to good way to look at it. And if you see this plot, this picture, the outermost, and this is you think of it as a hierarchy, and the outermost, the parent is the figure. And within this figure object, there are multiple axes. Do not confuse them with the actual axis with the eye. So axis is the plot, and you can have many of these in a single figure, which we'll take a look. And within an axis with the E, that's your plot. You will have your actual plot where you have the x-axis, the y-axis, the label, the actual line, the markers, sticks, and so on and so forth. So how do we use the subplot? So let's take a look. So let's start with creating a figure. As you saw, the figure is the parent. So I'm going to create a figure with fixed size, let's say 18.6. And I get back a figure. And now I'm going to add my axis. So let's start with ax1. I'm going to say plt dot subplot. And here I need to specify the number of rows, which is one row. So let's say I want 3 subplots in one row. So I would say then 3 columns, and this is the first subplot. And I'm going to repeat it for 2 and 3. So I would say the same thing. So the number of rows and columns remain the same, but this is the second, and this is the third. And then when I say plt.show, I should see something. Yes. So I see these 3 subplots. And now let's see how we can actually plot the content within this subplot. To start plotting what goes in each one of those axes now. So if you recall, we have the figure and then the axis. So I have 3 axes with the E. And what I can do is I can specify that this is going to be a bar chart, for example, and I can specify my X and Y. Oops, so my X is going to be, if we use the Uber example, so let's see if we still have that data frame. Let's make sure it's still good. Yes, it's there. So I'm going to use this and control forward slash. So I can say ax1.bar, and I'm going to specify year with the uppercase. That's going to be on my x-axis, and for the y-axis, it's going to be, I just want mobility for the first plot. And I'm going to say ax1 dot title mobility. I think it's set title, set underscore title. And if I run this, see that mobility gets plotted here. We have the same issue with the X labels. If you recall that we fixed here, we fixed earlier, I believe it is here with the trick on the using the indexes. Yes, this part here, if you recall, we'll need to do the same thing. We're going to skip that, and I'll do the same thing for these two axes. So, and if I change this to 2 and 3, and I'm going to change this to delivery, the title will be delivery, and this will be freight, and this will be freight. Oops, there is a typo here. X2 dot set title. There is something off here. Yeah, so not sure what is happening. So this looks clean now. So essentially in one figure, I have these three axes and subplots. And I had to individually, I created the subplot, 1 row, 3 columns, 1, 2, and 3. That is, if you're wondering in the subplot, what are those weird digits? You can skip the commas if you want here. So you can just say 131, 132, and you will see it in a lot of examples that you would see online that they skip the commas, but you'll get the same thing. So that's using the subplot. Now let's take a look at this wrapper method subplots and how there is a convenience function where you don't need to create this individual subplot. You can make it using one single call. So we added the subplot individually one at a time, and as I mentioned earlier, we can instead call the subplots method, the wrapper method, and wrap all this up into one single call. So what we can do is instead of subplot, we can call subplots and say the number of rows in our case is 1. The num calls equals 3. And our fig size will take the same fig size as before, which is 15. What did we give here? 18.6. And it'll return the figure as well as the axis. And if I do a show on PLT, so we added a subplot individually here, and we added 3 of those within a figure to create these subplots. However, we can use the subplots method to wrap all this up in one single call, like I indicated previously. So we can do something like this. So figure axis equals 50.subplot, and we can specify the rows is 1, the columns is 3, and the fixed size same as above, which is 18.6. And if we look at this, we see the exact same 3 subplots, but we don't need to individually create those. So the AX here is an array of axis objects. So what we could do then is just set those plots. So we can
call this thrice, but except it is going to be an array now. So it's going to be, this is the first one, and this will be the second, and this will be the third. And I'm going to just set delivery and freight. And you get the exact same thing. Obviously now you can set the title on these axis figures just like what we have done here. So if you follow the gist, it would be x0 and so this would be delivery and this would be freight. So it's really a convenience, much cleaner than individually adding it, and you can obviously have, depending on your presentation, you can change the grid contours, you can change the raised columns, all the customizations that we previously saw, they're all available and you can do the same thing. But this is what would be the recommended method. So even if you have one single plot, you can still call the subplots or the subplot method for creating the chart, right? So it's just a much cleaner way of plotting it, and you have all the other chart types using this, and we'll take a look at it in a future video. So that's it for this video. So we went through a introduction of matplotlib, we went through various chart types, and we touched on Jupyter Lab, we saw a bit of pandas magic, and finally we covered subplots. So this is meant